So my name's Oliver Giles, as Andrew's just introduced, from Linden Packaging. And just by way of introduction to what we do and what this is all about, Linden are transit packaging specialists. We particularly work with FMCG companies in the UK and Europe. And our key focus is on pallet stability. And we have a BHAG, which, if you're not familiar with that term, it stands for Big, Hairy, Audacious Goal, which is to remove movement in transport issues caused by palletized goods on the UK road network. Now, that is quite a big, hairy, audacious goal, but that's what we're working on nevertheless. So I thought I'd kick off just by looking at what the costs of poor pallet stability are, because we're all in the transport, someplace in the transport network, and what we tend to find is that a lot of companies will look at what they think the costs of poor pallet stability are, and they will look at all these things, you might say the tip of the iceberg, things that they can calculate. So they can calculate how much it costs them if goods get wasted because it was damaged in transport. They can calculate the cost of a returned load back to the factory. They can calculate the cost if they have to credit a customer, if a retailer rejects a load because all the pallets have fallen over. But there's a whole heap of things that a lot of people don't measure, and that might be what it's doing in the mind of their customer to their brand. And these points at the bottom here, the body of the iceberg, you might say, they're not in any particular order, but a lot of people actually overlook calculating what it costs to clean up any spills that have happened because pallets have fallen over on the back of a truck, and they've also overlooked what's the environmental impact of that. And of course, the number one aspect is, what if somebody gets hurt? What if this causes an accident that somebody actually gets injured, which, as we all know, you cannot put a cost on that. So there's a lot of things that commonly get overlooked, and we're finding this a lot as we talk to different people within the UK manufacturing industry. So there's a few statistics that I personally find quite frightening. UMOS, which, if you're not familiar with it, is a European Safe Logistics Association. They tell us that within UK and Europe, one person is either injured or killed every hour due to insecure cargo. Now, I find that quite a scarily fascinating statistic. And Packaging Digest have estimated that up to 11% of all palletized goods, when it arrives at its final destination, has some level of damage, which is also a scarily high number. So the question for all of us who work in either packaging or transport is, how are we mitigating these risks? There's a picture on the side of what that can look like. If a truck goes over, the curtain opens and ultimately product can fall out, which I've got a couple of examples of in a moment. So we've been looking at what are the safety impacts of poor pallet stability. So when a truck arrives at a logistics depot, or it might be at a distribution center for a big retailer, and the pallets inside it have collapsed, so they've fallen either against the curtain or against one another. What actually can happen? So you see the picture on the bottom right hand side there, we have got some pallets of a product. This, as you can see, is a beer, and half of them have actually fallen against the curtain. Now, it is almost impossible to open that curtain safely, because you can see how far those pallets have collapsed. If a driver unwittingly unbolted that curtain, undid the straps, those pallets would almost certainly come cascading down. So it's nearly impossible to offload safely. So question poses the question: how do you unload that? And the answer, apart from the obvious answer, very, very carefully, the answer is it involves an awful lot of additional labor, which on a busy unloading dock, they can very, very rarely afford. And I'll just draw your attention to the picture on the top right, because this is one of the, this picture represents one of the incidents that really got us on the journey of pallet stability. This is a situation that actually happened to us many, many years ago now. But it was late one December. We had a truckload of product. It was shipped from a manufacturing plant in Europe, direct to a customer in the UK. So Linden Packaging was involved in that. We were involved in the supply chain, although we never actually handled the product. And in this example, it was a dedicated truckload. It traveled something like about 1,500 miles across Europe, direct to an end user. It was an urgent shipment. And when it arrived at destination, the driver undid the curtain sides of the truck. And unfortunately, as he did so, 3 of the pallets collapsed, and they toppled out of the trailer, which knocked him down, pinned him underneath some products, and he sustained a very nasty fracture of his leg. It was a really, really horrible incident, and he had to be taken by ambulance to a hospital that was nearby. And obviously, there was quite a lot of chaos ensuing. The product had to be picked up. There was no driver because he was gone in the ambulance. They weren't able to move the truck because there was no keys. They were clearly with the driver. And a busy loading dock was obviously blocked for the remainder of the day until those keys could be obtained. But the real cost of this whole incident was that poor driver had sustained a really nasty injury. And he was in hospital in the UK. This was only a couple of days before Christmas, and he was unable to get home to be with his wife and family at Christmas. And to me, that it was just an entirely unacceptable scenario, particularly when you consider that a couple of euros or a few euros extra spent on packaging would have actually prevented that whole issue. So that was just an example, and this is just one of the examples that UMOS tells us about that they say happens every hour. So it's a really key one, and it just highlights for me the importance of why we're on this journey to improve pallet stability and remove movement and transport issues caused by pallets on our UK road network. So then we come on to plastic reduction, and as Andrew said just now, we were talking about sustainability and how this goes hand in hand with pallet stability, because every company, particularly the big manufacturing companies, they're under huge pressure to reduce plastic. Everybody wants plastic out of the supply chain. So whether it's beverages in a bottle, or whether it's heat shrink films around a pack, or whether it's the stretch film around the pallet, everyone's saying, can we reduce plastic? Can we make this out of recycled material? And in many cases, the answer is yes, we can reduce plastic, and yes, we can make it out of a recycled material. But when we make these changes, there is always a change in pallet stability, which is why we sometimes use this the saying every action has an equal and opposite reaction, which many of you, if you're science scholars, will know is Newton's third law. But we make a change and something else will change as a result of it. And often those changes, if you don't do the process thoroughly and test everything correctly, there can be a negative consequence of poor pallet stability as a result of chopping some plastic out of your packaging mix. So the drive to sustainability can, if it's not done correctly, can make this issue worse. Obviously, things like recycled content. We know from experience that, for example, a stretch film around your pallet, stretch film with recycled content in it, forms quite differently to a virgin material of the same specification. And that's not necessarily a problem, but you have to understand it when you're applying that film. So if you're making any changes, if your packaging teams are making any changes to packaging, it's really, really important to know what effect that has on pallet stability to minimize any risk of failure within the pallet network. So the way we go about this is in pallet stability testing. So here at Lindum, we've been working on a few things, but it's predominantly around testing. We've developed a laboratory for testing the level of stability of a pallet. And that testing, which I've got an example to show you in a second, but that testing tells us what might happen. It helps us to predict what's going to happen to that pallet. So what we're doing is we're scientifically creating forces and putting them on a pallet. So you can see an example there of a tilt test. And we know that if you tilt a pallet to 27 degrees, that's the equivalent of a G-force on the truck of 0.5 G. And we can obviously measure that. We can measure the angles of deflection. We know, we can gauge from that how stable or unstable that pallet is. But then the challenge comes when you get a pallet that is unstable. So one of the examples you can see on the pictures there is actually a pallet of bottled water. When you get one that you know is going to fail, you've then got the challenge, what do we do to fix it? And this is where packaging experience comes in, because you have to have some experienced packaging professionals, of which there's a lot out there, who can tell you what to do to stop that movement, you stop that, or to improve that pallet stability. And then so you make some changes, and then thirdly, you obviously introduce and implement those changes into the supply chain, and you monitor the data. Are there any instances of MIT or movement in transport? How frequently were they? What happened? And then you have to feed that data back and review. Was the changes that you made effective, or have you missed something? And so all the time you need feedback from the supply chain to make sure that what you've done on the packaging side was effective on the back of your truck. So I've now got a couple of videos which just highlight what difference packaging can make to pallets. So this was a project we worked on. Again, you can see this is a beer product, cans of beer. And in this example, we were seeing quite significant levels of movement. So this was deemed as a big issue, and it had to be sorted and fast. And there wasn't time to raise capexes to put fancy new machinery to apply packaging. It was an issue that actually needed fixing now. So these two videos are actually videos from our UMOS test bench. So this is actually part of what we do in the lab. So I'll show you the first one. And what this is doing is this is simulating an emergency stop from a speed of 50, let me get this right. This one here is 50 kilometers an hour. So this is what we call a 0.5 G test. And as we play the video, you'll see this is the emergency stop happening. The stretch film lets go from the pallet and the whole load collapses. If there wasn't a guard on our lab, that would have actually fallen right over. So I'll just play that again so you can see the movement, because it's quite a short video. So you imagine this is your truck coming down the motorway at 50 kilometers an hour. Something happens, the truck brakes, performs an emergency stop. Imagine if you had 26 pallets in the back of your truck doing that. Each one would hit another one, domino effects, and ultimately that can actually increase the stopping distance of the truck because of all that movement in the back. So then what we did is we said, right, okay, well, we can see that the stretch film is inadequate. It's actually not strapped the product to the pallet effectively. And we came up with this, it was a different stretch film. We got a specific stretch film for higher holding force on the pallet. So it was a completely different compound of stretch film, but it was the important thing was we were able to apply it using the same machinery that the factory already had in place. And this was the net result. So this is the same test, an emergency stop from 50 kilometers an hour. And you can see as the pallet stops, we get to about here as the breaking point. You still get a significant movement, but the whole pallet remains intact. And as the vehicle comes to a complete stop, obviously these vehicles are these videos are very slow motion. As the pallet comes to a complete stop, it returns almost back to its perfect original shape, which is really where we wanted to see this one. So that if that pallet now arrived with a distribution center of our friends at Tesco or Sainsbury's or one of the supermarkets, that wouldn't be rejected. They wouldn't look at that and say, that's a fail, you must take that back. So we know that by doing that change, we've then made a significant positive impact on the overall level of stability on that pallet. And yes, it did involve a little bit more plastic. It was, in this example, I think it was something like 12% extra plastic was needed. But to put that into context, by removing the heat shrink film the year before, they'd actually reduced plastic by about 65%. So us increasing that back a little bit was still a significant reduction on where we'd started out the year before. So I hope we found that insightful. My slides have gone the wrong way around. So then I just wanted to look at briefly what the root causes of poor pallet stability are. Because particularly when we're talking to people in the logistics industry, one of the first things that always comes up is driver behavior. How can you manage drivers? How can you stop them swerving around roundabouts, doing aggressive, harsh braking when it's not necessary? And that's always a challenging one to manage. And it's made worse by the fact there's been significant shortages of drivers. Our road system is arguably busier than it's ever been, and there's always going to be some unknowns. There's always going to be some unexpected things that happen. Another one of the causes that makes pallet stability issues happen is road conditions. It's one of the bugbears of many drivers up and down the country that there's poor road conditions, there's poor surfaces, there's potholes, you've got sharp corners, you've got challenging routes, steep hills, etc. All these things make it trickier and trickier to safely transport goods. And a very key one, particularly in the we do a lot in the food and beverage industry where there's a lot of automated warehousing. So you got automatic conveyor systems, you got forklifts. Sometimes forklift drivers can be very rough. Again, that's hard to manage. So when we put a pallet into the supply chain, there's all these different root causes of poor pallet stability that might have nothing to do with the pallet itself. So we know that our packaging format has to be able to cope with all these extra factors. And then we see a lot of instances where people are shipping double stacked pallets. They can that can lead to compression damage, or the top layer of product, if it's a fragile product, can be damaged. Can lead to more unstable loads. And then this is partly what we've already covered, but packaging performance, so the drive to lightweight, use different materials, use recycled materials, also has an impact. And a very, very key one is the pallet configuration. So if you've got boxes on a pallet or cartons, how are they stacked? Is it column stacked? Is it brick stacked? Which is best for the type and the weight of products? How's the weight distribution on the pallet? What can we do to adhere layers together? Some people use adhesive glue between layers to stick them together. Another thing we often do is put anti-slip layer sheets within. So there's all these things that can be done to mitigate these root causes of poor pallet stability. And then the key thing we're doing here is just focusing on what can we control. So you have to remember that the aim or the purpose of packaging is to provide protection for your product. It has to get your product from A to B. And there's all those things we've just looked at, all these factors that can happen on a journey from product manufacturer to retailer. All these things that can happen that can cause products on a pallet to fail, but we need to do so without excessive impact on the environment. So when you actually start to drill into this, you realize that there's a huge amount hanging on how your product is packed, not least because of the safety aspect. It has to get there in one piece without putting anybody's life in danger. Also, it has to do so without being unduly wasteful with the resources we have from on our environment, so our CO2 impact. So we really need to identify what the likely causes of damage are, and make sure that the packaging that we're using is fit for purpose. It's got to protect our products, but we've got to do so in the most effective manner, and that can be a very, very fine balancing line. So as a group of professionals in packaging and logistics, what we say is getting this right is our responsibility. And I say our as collectively because there's a whole group of people here. There's so much we need to get right to make this work. So really, that I'm probably a little bit ahead of myself, Andrew, but that really brings me to the end of the presentation I've prepared. And I think I saw a couple of messages popping in on the chat. I think there might be some questions pop in. So what I'm going to do is, if any of you have got any questions and would like to contact me directly, I'll be more than happy for any of you to do so. I don't necessarily know who all of you are. So I will just stop my screen share, and I'll put in the chat my email address if anyone wants to make contact with me directly.
Brilliant. That's great. Thanks, Oliver. Much appreciated. Questions so far which are popping up. When you saw in the video the wrapping that you've created, which significantly reduced the amount of lean and actually brought the packaging back to it's to the right state, if you like.
Yep.
I know this is almost an impossible science, but it's a great question in a way. So it says that if that vehicle was on the road, or those pallets were on the road with a vehicle, and that happened 3 times in the journey, do we know that the packaging would always do this? Is it sort of robust enough to withstand more than one event of the? Is it, as I guess where the question is aimed?
Yep, that's a great question. And we do know from testing we've done that if we were to perform that same test 3 times on that same pallet, incrementally it would get worse each time because you've already strained it to the point.
Yeah.
But this is where it's key to understand the performance of your packaging, because with something like stretch film, it gets stronger the more you stretch it. So if you've stretched it right to its optimum, there's nothing left to give in the film. So what happens is if you've stretched it properly, yes, you will see some movement when it that truck breaks, but what you won't see is the film becoming baggy, because it's what we see quite often is where film has only been, let's say, 30% stretched on application, and then you get the impact of an emergency stop, and all that additional stretch comes out of the film and leaves it looking really baggy. So I think the answer to that question is that it's really, really key to understand how you've applied that film in the first place.
Yeah. So it sounds like the technique of actually wrapping it is key to making sure that you have a better chance of withstanding the journey, so to speak.
Very much so, yeah.
Okay, we've got another good question come in, which is from Michael, and it's basically asking what techniques are used to balance safety risks with environmental aspects when making packaging decisions. So I guess the question is then is one that I've always wondered about, is when the packaging sort of designers and manufacturers are thinking about how they're actually designing wrapping and so on, how do you build in your environmental aspects and obviously sustainability more so now, in terms of saying, yeah, this is the right packaging material to be environmentally friendly and sustainable, but it'll still do the job. Like how do you make those decisions?
Yeah, and this is one of those things that it's not there is no right and wrong.
Yeah.
There's a couple of key pointers we would say is to know the CO2 impact of the materials you're using, because we see a huge amount of shift at the moment from away from plastics and towards board or cardboard or corrugate, which is great because corrugate is easily recyclable and there's widely available streams to recycle it. However, it's important to be aware that cardboard does have a higher CO2 per kilo footprint than plastic. So there's a really key piece in actually doing the analysis and understanding what the environmental impact of your packaging is, because there's what we've seen a few examples where the best, most well-meaning or well-intentioned changes have actually made the CO2 impact higher. And if in doing so you've also made a reduction in pallet stability, you've kind of almost gone backwards.
Yeah, so makes sense. Yeah.
Very good question, and I can't answer it
No.
specifically.
I wouldn't want you to, but it is a great question from the point of view of that, within and sort of I'm part of the logistics and retail group for IOSH as well. And it's a question that gets asked in logistics and retail, is that kind of understanding, if you like, that yes, we all want to be environmentally friendly, but if the wrapping standard or the wrapping or the way of wrapping, so to speak, is such that we encounter more lost loads and damages, we're potentially causing more damage to the environment by the lost loads, etc., and the stuff having to be picked up or cleaned up or disposed of than we are saving in terms of the wrapping that we're not using to secure the load in the first place, if that makes sense.
Yeah, it does. Yeah.
Brilliant. So, is another question that's come along is, in terms of when you've done your trials and you're looking at your wrapping, and you might have partially answered this already, but I think it's a good one to look at. How important is placing the wrapping correctly, and does tightness of that wrapping play a part in load security as well?
Very, very much so. Yeah. So yes, it is extremely important. To give an example, one product I've worked on that we were trying to increase performance, so increase load stability. We found that there was very few wraps around the bottom of a pallet, and there was a lot more wraps around the top of the pallet, which actually is, in a lot of cases, is the wrong way around. We always work on, for maximum pallet stability, you should wrap a pallet a bit like a Christmas tree. You've got more at the bottom, a bit less in the middle, less at the top, to give maximum stability. And in that particular product that we were working with, we pretty much reversed the order. So we changed where it was putting the wrap, and without any additional wrap at all, we got I think it was a 2 or 3 point improvement in the pallet stability with no additional packaging. So that kind of highlights how important that is.
Excellent, thank you. There are no more questions in our question bank at the minute, so unless anybody's got any direct questions they wanted to ask Oliver, what we should probably do is just do a couple of closing remarks on behalf of the branch. First of all, to say to Oliver, huge thanks for coming along and doing today's talk. Much appreciated. I certainly found it interesting. Oh, you're welcome. The two things I need to say, sort of from a domestic and a point of view, is that if you want to know, and there are lots coming up, Future Teas branch webinars and so on, you'll find them on our LinkedIn page and also on our website, and you'll see them there. So do please come along to the next ones. Lots of good stuff coming along. You'll also see that we're planning some face-to-face meetings in the coming year, which is going to be great. A chance to get back together and talk to people, perhaps in the old-fashioned way like we used to. And I think, as I already said right at the start, we'll share the presentation. Everybody will be able to get it from the website. If you have got a question and you didn't want to ask it now, which is fine, do please email Oliver. His email's there on the chat. Or if you get in touch with us via the branch website, we can make sure that Oliver gets the questions. We'll come back to you. No more questions in the box, which is fine. So on behalf of the branch, Oliver, thanks so much for coming along and doing that. Really, really much appreciated. And to everybody, thanks for joining, and have a good rest of the day. Thanks a lot.
Thank you.